section 2.4, we're going to look at absolute value. Absolute value, which you've all heard of before, but the way we're going to think about it today is definitely outside the box. It's something that you probably haven't been open to before. When you hear absolute value, what do you think? What do you think of right away when you hear absolute value?
Distance from zero.
Distance from zero.
I kind of think positive, I know it's distance from zero.
It's always going to be positive. You know it's distance from zero. You think positive. If I said to you, what's the absolute value of -3? What would you all just tell me? 3. You wouldn't in your mind say, well, -3 is 3 units away from 0, therefore it's 3. Most people just remember, take the positive value. But really, as we said a moment ago, as Georgia said, it's the distance from 0 on the number line. Okay, the distance from 0. So the absolute value of -20 is just 20. Because -20 is 20 units away from 0. It doesn't matter if it's negative or positive anymore, but it's the distance between them. Okay, the distance between them. Take a look at this chart now. And this can be very confusing at first, so we want to go over every part of it. First, if we use the idea that it's the distance from 0, when we have something like this, let's take a look at the first one here. Absolute value of x is equal to 0, so row 1 we're looking at right now. Well, what this tells us is that x is 1 unit away from 0. How many numbers occur that are 1 unit away from 0? How many different numbers occur? 2. What are they, Francis? Yeah, -1 and 1. So if we're looking in this case, thank you, and we're looking for -1 and 1, we'll see on the number line, this is where they're appearing right here. So when we have a problem that says, what is the absolute value of 1, the absolute value of x equals 1, we have to remember that -1 and +1 are 2 of our options. So we end up with an OR statement. So what we're going to notice, it's an OR statement. Remember the other day when we talked about inequalities, we had AND statements and we had OR statements? Those are going to come into play here as well. So whenever you hear the absolute value of some number x equals a quantity, just know that it can be positive or it could be negative. That's our beginning point. Then when we move on to the second line is where it gets confusing. If I told you the absolute value of x is greater than 1, what are some possible values x can take on? What could you put into the second row here for x that would make that true? Liam?
-2.
-2. Because if you take the absolute value of -2, it becomes 2, which is still greater than 1. So some negative number bigger than -1 in the negative direction. What else?
Just anything greater than 1.
Okay, anything greater than 1 in the positive direction. So what we're looking at here is these two regions. We're thinking about anything bigger than -1 but in the negative direction, and anything bigger than +1 in the positive direction. So what kind of a statement does this become? This becomes an OR statement. Okay, so we're going to end up having here is that x is less than -1 or x is greater than the +1. So we have this region of possible solutions. Any of those, when plugged in here for x, gives us a true statement. So you should write down a little note. Here's what your note should say. That when you have the variable here on the left side and a greater than symbol, it's going to become an OR statement. Again, this is a greater than symbol here, or greater than or equal to, either one. When you have a greater than or equal to symbol, and you have the variable inside of the absolute value on the left-hand side, like it's set up here, it's always going to end up being an OR statement. It's always going to end up being an OR statement.
Because of the greater than equal sign?
Yes, and in a minute we're going to see with the less than, it's going to end up being an AND statement. And an easy way to do this is to start by rewriting the problem without the absolute value. So you could write it like this. That's what it would look like without the absolute value around it. Then what you can do actually is do it again, but flip the sign and negate whatever the answer is on the other side. So write, instead of x greater than 1, write x less than, but make it a -1. And that's exactly what we got. If you look back up here, we have x less than -1 or x greater than 1. That's what's showing up here. So whenever you have these problems, you can write it once the normal way without absolute value. Then you can write it again, but you can flip the sign and negate whatever constant is over here on this side. Okay, and it will always work this way. It will always work. So it's the same thing is going to occur for the next part. Write it the way it is. Just rewrite it as x less than 1 for this third line. Okay, but then we're going to also flip the sign and negate it. So these are our answers for the AND statement, the third row. And you'll notice they both occur here. Well, what numbers are less than 1 and bigger than -1? It's the numbers in between them. Hence an AND statement. Okay, remember that we're looking at the quantities of x that can be in between -1 and +1 for this third line, which is what makes it an AND statement. This becomes an AND statement. So again, if you have a greater than, think of or. If you have a less than, think of and. Okay? Greater than or, less than and. You can always just start by rewriting them all like this and realize what they are as you go through the process. But it might be easier to remember, again, that a greater than is or and a less than symbol is going to yield an and statement. Okay? Let's look at an example of this to maybe make a little more sense. Want a question first? Yeah, shoot.
I'm just a little confused between like or and and.
Okay, remember the or statement is when two sets of answers go in different directions? So it could be greater than 4 or less than -3. And then other times we had answers that they were overlapping on each other. So when it's a less than symbol for absolute value, we're going to notice that less than's always correspond to and statements. And greater than symbols end up corresponding to or statements because of their graphical solution. When it's all numbers greater than 1, it means all these numbers, but all these numbers bigger than -1 also. And clearly they're going in opposite directions. That means it's or. But here, if we look at this one, what's any value that's going to be less than 1? It's going to be like 0.5 or -0.5 or -0.2. All the values between 1 and -1. And when you have something in between, that's the overlapping of these two sets that make it an and statement. Okay? So for each of these, you can start by rewriting them, or you can look at what it is. And we'll do it both ways so you can see. So example 1, we've already solved for the value of 14. We don't have to do any work over here. What we can do at this point in time is say, well, this is just equal to. Right? It's not less than, it's not greater than, so we don't have to worry about an inequality. It's just equal to. Well, what value could 2x minus 4 take on? What value could the expression 2x minus value or values could the expression 2x minus 4 take on?
2x plus 4.
Now be careful. I know what you're saying there. Why would you say plus 4?
Because it's in absolute value.
Yeah, but that's not how it works. Remember what we said a minute ago. Go back to your notes. Look at your previous slide, Liam. And when we said absolute value of x equals 1, we said that x could be 1 or it could be what? Yeah, so here, this quantity could be 14 or it could be what? Negative what? 14. So remember, the entire quantity is what we're looking at. It could be positive 14 or the whole quantity could be negative 14. Because either way, if we take the absolute value, you get back to 14 in the end. Dave?
9 and -6.
So you end up getting, good. So you end up getting 9 and -6. This is going to yield 9 if you solve. And this is going to yield, let's see, not -6, I don't think, right?
Yeah, because -12. No, I mean not -5 actually.
No, -5. Okay, I was going to say we have -10 over 2. I thought I was doing it wrong there for a sec. So we've got -5 or we've got 9 as our answers. Now, let's think about what this actually means. If you plug a 9 in back up here, what are you going to get on this side?
You're going to be, like 14.
14. If you plug a -5 in though, what do you end up getting before you take the absolute value?
Before you take it, you're going to get negative 14.
You get the -14 back where you started from. So whenever you have absolute value, you can think of taking whatever's inside the absolute value, setting it equal to the positive value, and then setting it equal to the negative value. Okay, so again, when you have absolute value, leave what's inside the absolute value alone. Don't alter this number here, but only alter what's on the outside, and make that one positive and one of them negative, showing us that you could have either positive or negative. Because no matter what, if you plug -5 back in, you end up getting -14, but you're going to take its absolute value, so it becomes 14. So with these problems, how many answers are you always going to get? Yeah, you're going to get 2 answers every time because of the positive or negative value of that constant on the right-hand side right here at 14, okay? Let's take a look at the next one that might be a little tougher. And again, make sure you're checking these as you get your answer. So this one we have a less than symbol. So we can go back to our table and realize that it was the third row of the table, which means an and statement. And we can start by saying that. Or we can just go ahead and do the problem and see what we get. Okay? It's good to know that's an and statement, but let's go ahead and just write out the problem. So on the first part, let's rewrite it. And on the second side, let's say it's not the same, but it's now going to be greater than negative 5. Okay, so remember, what did I say earlier? Start by rewriting it first, then write it with the flip sign and the negative of the quantity that was a constant on the outside. On the right-hand side. Okay, so this is a replica of this. This is the same thing, but now we flipped the sign and we made it a negative there. Okay, that will give us the same exact equivalence of using an and statement. It's no different from that. Okay, try and solve these simultaneously or separately. We'll come up with an answer for them. So subtract 6 in both cases, leaving behind a negative 4u in both cases, but different answers on the right. When you divide by the negative 4, what do you have to do? Flip the sign. So divide by negative 4, and make sure you flip the sign of the inequality. Now these are the two answers we're going to get, because this ends up being 1 over 4, which is 0.25, and 11 over 4, which is 2.75. So for this problem, if you didn't remember and or, how could you then come up with your answer? If you didn't remember whether this was an and or an or statement, what could you do at this point? Okay, look at the signs. That might help us. So what do you mean by look at the signs? Because you could do that, Dave, yeah.
Well, look at the way they're facing.
So a number is bigger than 0.25, but less than 2.75 means it's in a certain what?
It's in a certain range.
In a certain region, which is an and statement, right? But we could also graph these simultaneously, right? Right, Tori, you're going to say? Thank you, sorry. So let's graph these on the same number line and just verify this. So here's a quarter. Here's 2.75. Numbers bigger than a quarter look like this. Numbers smaller than 2.75 look like this. Where do they overlap? They overlap between those two open circles, from 0.25 to 2.75. So here's my actual solution, and I'll draw it in red. Some of you did this, but you didn't go on to draw your solution. So your solution would look like this. Okay, that's what the solution would look like. It'd be the highlighted region between a quarter and 2 3/4, not including the endpoints. So this is clearly an and statement because we have an overlap of two sets, but it really might help you a lot to remember this format. When it's a less than and it's in this standard form like this, it's going to end up being an and statement. Okay? So what would your solution set look like? What would your solution set look like for this? Who can tell me what the solution set would be for this problem? Tori May.
2.5 is less than u.
0.25.
Yeah. And then is less than 2.7.
Good. Be careful, you said 2.5. 0.25, less than u, less than 2.75. So u ranges between those two quantities. Georgia?
I wrote it in fractions, is that okay?
Yeah, if you wrote 1/4, less than u, less than 11/4, that works, absolutely. Fractions are fine with me.
Oh, just to remember, like the and and the or.
Yep.
And Joe's, when you look at it, you tilt your head to the left, what's it called? The less than sign, you make an A.
Oh, that's true. So Tori May is saying, look back at the original, and when you tilt your head to the left, that makes an A almost. So it's like an and statement. Yeah, you just got to remember to tilt your head to the left. So you tilt your head to the right, it kind of switches it up completely. Yeah, that's true. Here's what you can also remember. If something is less than a quantity, it means you're limiting it to a certain amount. So you're within a certain range. If it's got to be less than 5, it means you're between 5 and negative 5, really. That's what less than means. Somewhere in there. But if it's greater than, it's exceeding. So it's going outward, like an or statement, when it's greater than. Okay? Good. I like that. Good point. Next example. So for this one, it looks at first like we have another less than, right? Like it's an and statement. But which way is this written?
It's reversed.
Yeah, so if you want to restart by rewriting it, you can.
I was tilting my head to the side, but then
Because this is the form that we looked at these in earlier, right? This is what we looked at it like. Now it's a greater than or equal to sign, clearly. So this is going to be an or statement. Okay, so it's got to be the x on the left-hand side inside of the absolute value, and the constant on the right-hand side. That's the key here. So we have to make sure it's in this form. Because if we looked and turned our head left here, it would look like and again, right? So it's got to be in the correct form, and now we'll see that it's not an and statement yet, it's an or statement. Let's rewrite this. Okay, let's write it 2 times. First, 2 plus 1/2 x greater than or equal to 3/2, and 2 plus 1/2 x less than or equal to negative 3/2. Same process as before. We're breaking up our absolute value into the positive value and into the negative value. But remembering when we have the negative value, what do we do with the sign? Because it's like you're multiplying by -1, really. Okay? Again, think about this as if you're multiplying by a -1, so you have to flip the sign when you make it a negative for the absolute value. Alright, so for this one, what's an easy way to make this problem much simpler right away? Multiply everything by what? 2. Okay, multiply everything by 2. Why do I want to multiply by 2? To get rid of what? Yeah, the fractions. So 2 by 2 is 4. The 2's just cancel. And this is greater than 3. 4 plus x less than or equal to -3. Okay, it makes it a lot easier to do this problem than using fractions. Whenever you can clear out all denominators, go ahead and do it ahead of time.
This is very frustrating to me when we get rid of decimals and fractions. Everyone knows how to do it so fast.
Okay, but ask a question because we're running out of time, Summer.
Yeah, what? Couldn't you do it with any like a multiple
Yeah.
of 2?
Absolutely. You can multiply everything by 4, and this would become 8, 2x, and this would be a 6. All you need to remember is when you have a denominator, if you multiply by whatever the least common multiple is of the denominators, you'll clear them out. So if this had been a 2 and this had been a 4, you should then multiply by 4. Yeah, whatever the largest denominator is. Okay? So let's subtract the 4 now from both sides. So we get x is greater than or equal to -1, and x is less than or equal to 7. But it's clearly not an and statement because those can't overlap, right? What kind of a statement is it? It's an or statement. Let's take a look at our answer. -7 is back here. Let me move this page up a little bit. That's -7 back there. And here's -1. So when x is greater than or equal to -1, it looks like this. Colored in to the right. X less than or equal to -7 looks like this. To the left. Again, it seems like it's misleading, but you have to remember that you're like kind of switching. This portion here is going there. This portion there is graphed over here on the left-hand side. So when you move this over, these are the answers you're going to get. Please realize, these don't overlap. There are no numbers that are bigger than -1 and less than -7. It's impossible. It's an or statement. Okay? You got to be careful with your negative signs along the way. Worth.
Can you just check that? Because I'm having like check your answer into the equation.
Sure, so pick a number bigger than -1. What's a number bigger than -1?
2.
An easier number. Come on.
0. 1.
0. Right? 0 is bigger than -1. It's easiest. Plug 0 into the original word. 2 plus 0 is greater than 3/2. 2 is definitely greater than 3/2. That is true. Try a number less than -7, like -8. This will give us -4 here, right? 2 and -4 is -2, but its absolute value is 2. That is also bigger than 3/2. That works. So you can check numbers to see if you're right by picking numbers in that region. Okay? I know this is tough, guys, but you need to just be meticulous with your work. Move the 4 over, this is what you get. Move the 4 over, this is what you get. And then this portion appears over here. This portion appears over here. So they're on opposite sides. Let's see. Let's take a quick look at the beginning of number 4 just to start you off. Example 4 says solve 2 times the absolute value of m plus 4 greater than 5 times the absolute value of m minus 8. And the reason I'm doing this problem is to remember that absolute value of m can be treated like any other variable as long as you have like terms. So start by subtracting 2 absolute value of m from both sides. Yielding 4 greater than 3 absolute value of m minus 8. Add the 8 over to both sides, you're going to get 12 greater than 3 absolute value of m. Well, 3 is a multiplier on the outside, so divide by the 3. So you get 4 greater than absolute value of m. Well, when is m, in this case, if you read it from right to left, m less than 4? Well, m is less than 4 when it's 3, 2, 1, but the absolute value. So it could be negative 3, negative 2, negative 1. So pretty much we're saying that this has to be between negative 4 and 4. So our solution set is simple. You don't even have to break this up really. All we do is this. Okay, that's our solution set. Because again, absolute value of m is less than 4. It tells us that m can take on any quantity as long as its numerical value is something less than 4. Now, again, we're looking really at the magnitude, so we know that numbers like negative 3, negative 2, negative 1, those also work, because when you take the absolute value, they're still less than 4. So our solution set for this would be m is the numbers between 4 and negative 4. So number 5 says solve 1 less than absolute value of 2 minus r, which is less than or equal to 2, in graph its solution. The thing we want to notice right away is that this is clearly an and statement because we have something in between here. So we have two things going on. Let's break them up just to see what that is. But what you'll notice next is actually that we have and or statements written together. On the left-hand side, we take a look at this. Whenever we see a greater than sign, and that's what this is really, even though it looks like less than because we're reading it this way, this quantity is greater than 1. That's an or statement. Again, greater than is an or. It's like on the outsides. So we could also look at this by saying, all right, well, 1 is less than 2 minus r, but negative 1 is greater than 2 minus r. But the or part is the tough part. You have to carry down the and. Over here it says it's less than or equal to 2. Well, whenever a quantity x, or r in this case, an absolute value is less than a number, it's an and statement. It's in between them. So here what we really have is that 2 minus r is less than or equal to 2, and 2 minus r is greater than or equal to negative 2. So what we have here is 4 different parts of the problem. Okay, it's this or statement and this and statement. So let's solve these each individually. Start over here, we'll work this one, then we'll work this one, then this one, then this one. First we can start by moving the 2 over by subtracting 2. And that's negative 1 less than negative r. Or, in this case, again subtract 2, negative 3 greater than negative r. Over here we're going to subtract the 2, we're going to get negative r less than or equal to 0. And when we subtract 2 on this side, we get negative r greater than or equal to negative 4. Continuing to solve, we have to remember to flip our signs of all these. So this becomes this. This becomes this. This next one becomes this. And the last one becomes this. So we know that r is greater than 1. We know that r is, let's start over here. R is less than 1. R is greater, or it's greater than 3. And r is greater than 0. And r is less than 4. So we have to graph these on a number line. Let's take a look. R less than 1, well, we're going to have 0, 1, 3, and 4 are some of our critical points here we have to focus on. So r less than 1 looks like this. Or r greater than 3 looks like this. So that's the solution to this part right here. That's what it's going to look like. But we also know that r is to be bigger than 0. This is an and statement here. So these things have to hold true. R has to be greater than 0. Well, this portion is not greater than 0. Everything bigger than that is greater than 0. So technically, technically greater than or equal to 0. So technically we have to stop here with a closed circle. Because that does not hold true to this part right here. In the next part, everything is less than or equal to 4, means that it has to stop at 4. So this portion is not really true. But everything else holds true. So our final answer is just these little regions, and I'll erase what's left over, what we don't need now. We don't really need this part here. We don't really need this part here. Because again, these statements are made true, like going this way and going this way, but keeping r greater than or equal to 0 by putting a stoppage there, and keeping r less than or equal to 4 by putting an endpoint here, gives us our final solution. So in solution set form, this one is probably the most confusing. Let's take a look. So r is in the set of numbers between 0 and 1 first. So we go 0, less than or equal to r, less than 1. That's the first part. Or r is in the other solution set. 3, less than r, less than or equal to 4. Your homework from this section is from 2.4 and then one review problem from 2.8.